The SDLC Umbrella Tasks are sometimes called management activities, as they are guided by the project management plan. Umbrella tasks are not contained within a single phase, and they can remain in force throughout the entire life of the project. Let's explore these umbrella tasks, which involve many departments to ensure the success of the project. SDLC umbrella tasks are defined by activities, not clearly defined work phases. The project management plan guides how the umbrella tasks are implemented in the project. Software project management includes a wide range of activities that keep the project manager very busy. Detailed schedules must be created and tracked, along with current cash flow, to stay within the approved budget. Software releases to QA and production must be managed and controlled, and the project manager must coordinate activities with many project infrastructure and support groups. The project will need development environments and data management controlled by the IT department, and office space and furniture from facilities. Finance controls the project's cash flow, and senior management monitors the project's progress through status reports and reviews. Human Resources facilitates the ramp-up of skilled workers for the development team, and marketing, training, documentation, and logistics are required to transform the software application into a deployable product. A project is controlled and evaluated through a series of formal technical reviews. Reviews are used to formally accept artifacts, signifying a phase of the SDLC is complete. These artifacts are normally a document, such as the requirements, design, test plan, or test documents. They may also include diagrams laying out the system or database design. Review participants are qualified team members and stakeholders who determine the completeness, accuracy, and suitability of a project artifact. Stakeholders may hold additional formal reviews to control project scope and cost. One example is change management reviews to investigate and improve a requested requirement or scope change. Software quality assurance provides oversight across the entire software development process to ensure requirements for the project are fulfilled and the software produced is of high quality. QA is responsible for promoting standards and best practices, as well as ensuring the project adheres to industry regulations and business procedures and processes. QA oversight encompasses all software tasks and phases, but the main focus is evaluating and validating the resulting software application. This evaluation focuses on two major areas: functional requirement specification compliance and non-functional requirements such as robustness, performance, and maintainability. Software configuration management is concerned with how the project will implement and control the aspects of software archival, update, build, and versioning. This includes the choice of a CM system, which provides archival and storage of not only the software developed, but also the associated test code, build files, configuration, and documentation. CM systems provide a controlled change process for software, which logs modifications made to the code base, when they were made, and who made them. The CM system enables the project to use revision controls to establish baselines, ensuring a repeatable build process for released code. CM systems can also be linked to the defect tracking system to tie code modifications to specific defects. Reusability management is the process of identifying software objects, functions, components, and modules which can be reused in other software modules or projects with little or no modification. Reusing existing software can significantly reduce project effort and cost in both the development and test phases. However, a successful software reuse effort requires buy-in from both management and development. Management must give the developers the extra time needed to create reusable software components. And the software developers must keep reusability in mind when designing and developing software. Software reusability affects multiple areas, including build management, packaging, distribution, deployment, and installation of the reusable components. And a reusable component in production needs special consideration when dealing with configuration, maintenance, and upgrades to ensure modifications do not affect other areas where the component is being used. Over the life of the project manager must gather objective, quantitative measurement data and analyze it to influence future actions and plans. The data gathered can be compared to metrics around schedule, size, complexity, cost, and quality to evaluate the current project status with respect to the project plan. This analysis allows the project manager to characterize the current processes and environment, identifying the root causes of issues and inefficiencies, and making the necessary changes to keep the project on course. Software measurements and metrics influence planning for the schedule and budget and drive software development optimization. Documentation involves several areas and departments. The development and QA teams will prepare their own SDLC project documents, including the requirements, design, and test plans. These will have their own archival and control processes, normally in the SCM system. Documentation used in production are produced by technical writers. They include the user manuals, which describe the software's interfaces and features for end users, and the support manuals for the operators and administrators. Marketing will produce its own documentation used to sell the software, including brochures, white papers, and promotional material. Once documentation is written, there must be a process to review and accept it, then produce multiple copies to accompany the software product. Risk management is an ongoing activity in any project which attempts to identify, measure, and assess risks, then develop strategies to mitigate or manage the risks. For each risk identified, analysis is performed to determine the possibility of the risk occurring and its effect on the project. Risks are associated with data that is objective, timely, and accurate. This associated data is used to identify and document thresholds, which will act as indicators that a risk is occurring. Once the risk plan is established, it must be used to monitor the project data for the predetermined data thresholds. When the metric risk indicators pass the predetermined threshold, it triggers the project to invoke the strategies developed to handle the risk.